Alright everybody, in this video we're going to learn how to solve for mass. So solving for m. So again, if we start out with our normal equation for gravity, when you use some algebra, we can multiply both sides by r squared. These r squareds will cancel out on this side. Then we can divide both sides by gm2. The g's will cancel out and the m2's will cancel out. And what we're left with is fg times r squared over gm2 is equal to m1. And just for clarification, right, m2 and m1, the numbers don't actually matter. You could write it the exact same way with them switched, totally arbitrary, up to you which one is which. So let's use this new equation in an example. So let's say got a person on the earth. They're standing on the scale. So we know the mass of the earth. Is 5.97 times 10 to the 24 kilograms. We look at the scale tells us that this person weighs say 600 newtons, and we know that they're on the surface of the earth, so this r is going to be the radius of earth, which is 6.378 times 10 to the 6 meters. Now if we bring back that equation that we had for mass, Fg times r squared for gm2 equals m1. We just gotta plug them all in. So let's see, we get 600 newtons times 6.378 times 10 to the 6 meters, whole thing squared, divided by 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared times the mass of the earth, 5.97 times 10 to the 24 kilograms, and that's going to give us 61.4 kilograms. And so what this means is that a person on the surface of the earth, if the earth is pulling them down with 600 newtons of force, we know that they must have a mass of 61.4 kilograms. And again, one way to think about this is we know that they're going to be accelerating towards Earth at that number that's around 9.81 meters per second squared. And we need to figure out the force that it would take. Well, in this example, we're given the force, so we know that it takes this much force to make them accelerate at 9.81 meters per second squared. What mass must they have? Okay, because m1 and m2 are arbitrary, we could have also said, given a person with a mass of 61.4 kilograms, say they had a weight of 600 newtons, what is the mass of the planet that they're standing on if the radius is 6.378 times 10 to the 6 meters? And if we plug all of that in, we'll get exactly what we want, which is the mass of Earth. So just to set that up, and now if we use the person's mass instead of the Earth's mass, what it will give us is now the Earth's mass. And again, that's just because the two masses are interchangeable, right? Mass 1 and mass 2, you can choose which one is which.